Hey everyone, this is Chandan and I welcome to my channel, The Learning Field. Okay, so today 15 August 2022 is the Independence Day of India. So happy Independence Day all of you. And we are going to discuss in this series. This is the part 4 video of ODE practice series, though which already continue. Okay, so this is the part 4 video and we already make part 3 sessions to practice ordinary differential equation. Those who are new, those who are not watching the previous video, I will share the link in the description and also here in the iTab. Okay, you can check those links for your practice for the upcoming CSIR NET and GATE exam. Okay, so today's first question is the question says that, okay, just a minute. And in the last question I discussed up to question number 24, and for the technical issue the question is not completed, so I will continue today from question number 24. Okay, so question number 24 says that let y1 and y2 from the fundamental set of solutions of the differential equation d2y dx2 plus px into dy dx plus qx into y is equal to 0. Okay, so this is the differential equations where a less equal to x less equal to b. This is the differential equation, and px and qx are continuous in the closed interval ab, and x0 is a point in AB, then both y1 and y2 cannot have local maximum at x0. Okay, so here the concept which is we used is that, so between any two zeros of y1x, since y1 and y2 are fundamental solutions, that means y1 and y2 are linearly independent solutions. Okay, so y between any two zeros of y1x or y2x there is at least was 1 0 of y2x, okay, or y1x. So this is the concept for behind these questions. Okay, so between any two zeros both y1 and y2x cannot have a local maximum at 0, and another concept is which is we used here, that is y1x and y2x cannot have a common point of extrema, okay, of extrema. These two are the concept. So here option 1 says that both y1 and y2x cannot have local maximum at x0. Okay, so x0 is a point in between closed interval open interval ab. Okay, so that means this is the cannot have as a common point. So this is y1, the option 1 says that both y1 and y2 cannot have a local maximum at x0. So option A is clearly correct option. Okay, the option B says that both y1 and y2 x cannot have a local minimum. Yes, this is also correct option. B is also correct. The option C says that y1x cannot have a local maximum at x0 and y2x cannot have a local minimum at x0 simultaneously. Okay, so this is also a correct option because y1x and y2x cannot have a common point of extrema. Okay, so this option says exactly that, that is y1x cannot have a local maximum at x0 and y2x cannot have a local minimum at x0 simultaneously. Okay, so this is correct option, and both y1 and y2x cannot vanish at x0 simultaneously. Yes, C is also correct and D is also correct because both y1 and y2 cannot have a common 0. There is another one concept which is both y1 and y2 cannot have a common 0. Okay, so this is another concept one. So from this concept this question is clear. Okay, so here ABCD all are the correct option. Now go to the next question. I think this will be question number 25. Okay, so the question number 25 says that let u and v be two solutions of the differential equation y double dash plus px into y dash plus qx into y is equal to 0 on closed interval AB. Okay, on closed interval AB, let W denote the Wronskian of U and V. Okay, so W is equal to Wronskian equal to W of U and V. Okay, then option A says that WUV vanish at a point x0 belongs to AB. Okay, so x0 belongs to closed interval AB, vanish at x0, then this implies U and V are linearly independent. Okay, so we all know that the Wronskian of a function W is either vanish either throughout the interval, throughout AB here, and or never vanish. Okay, never vanish. And here option A says that it is vanish at x0 belongs to A. That means W, if W at x0 this is equal to 0, this implies W at x this is equal to 0 for all x belongs to closed interval AB. Okay, so this is the, and Wronskian 0, this implies the functions that the solutions U and V are linearly dependent. Okay, that means option A is clearly true here, and option B says that WUV vanish identically on AB, implies UV are linearly dependent. This is also true option. So A option is correct here, B option is also correct here. In A it says that at 1.0 then U and V are linearly dependent, and we know that if at 1 point Wronskian equal to 0, then this is completely 0 throughout the interval. Okay, so here option A and option B, these two are true. Then option C says that if WUV does not vanish at any point on closed interval AB, but U and V are linearly dependent. This is not true obviously, because if W is not vanished, then this is linearly independent. Okay, Wx not equal to 0, then this is linearly independent. Now go to the next question. Just a minute. The next question says that, so the next question is question number 26. Okay, question number 26 says that let xt and yt satisfy the ordinary differential equation dx dt this is equal to minus of x plus ty, and dy dt this is equal to tx minus of y. If xt, yt and x2, x1t and y1t, x1t, x2t, sorry, y1t and x2t, y2t are the two solutions, and phi t equal to, these two are the solutions of these two equations, and phi 2 this is equal to x1t, y2t minus x2t and y1t. Okay, this then d phi dt, we have to find the value of d phi dt. Okay, d phi dt. Here four options are given, minus 2 pi, and 2 pi, A is minus 2 pi, B is 2 pi, C is phi, minus phi, and D is phi. Okay, so this is the question. So how we can solve these questions? Now first, these two are the solutions of these two equations. So first we satisfy these two solutions. That means we get x1 dash, this is x1 dash, this is equal to minus x1 plus t of y1, and x2 dash this is equal to minus x2 plus t of y2. This, and the second one is dy dt, that means y1 dash this is equal to t of x1 minus y1, and y2 dash this is equal to t of x2 minus y2. Okay, these two we just, since these two are the solutions of these two equations, we just satisfies these two equations. Okay, now it is given that phi equal to this. Okay, so phi equal to this, that means, so if we differentiate phi, that means d phi dt this is equal to, these two are the functions of t, that is x1 dash into y2 plus x1 y2 dash minus x2 dash y1 minus x2 y1 dash. These are the all differentiation with respect to it. Now we put the values of this differentiation from these four. Okay, so this is equal to x1 dash into y2, that means this minus x1 plus t y1 into y2 plus x1 into y2 dash means this value, that is t of x2 minus y2 minus y1, this minus y1 into x2 plus dash, that means this one. So minus of x2 plus t of y2 minus x2 into y1 dash, that means this one. Okay, so this is t x1 minus of y1. Okay, now we just simply multiply. This is equal to minus of x1 y2 plus t y1 y2 plus t x1 x2 minus x1 y2 minus plus x2 y1 minus t y1 y2 minus t x1 x2 and plus x2 y1. Okay, now this is equal to t y1 y2 cancel with this and t x1 x2 cancel with this. Okay, so these two are cancelled. Now minus x1 x2 minus x1 x2, so minus 2 x1 y2 and plus this and this term, so this two term gives 2 x2 y1. Okay, so this is equal to, if we take common minus 2, then we get x1 y2 minus x2 y1. Okay, and this is the value of phi, so this is equal to minus 2 phi. Okay, so minus 2 phi is the clear answer, that means option 1 or option A is clearly correct here. Okay, now go to the next question. Next question, just a minute. The next question says that let x belongs to, okay, let x belongs to, let x from 0 3 pi to r, okay, 0 3 pi to r be a non-zero solution of the ODE x double dash t plus e to the power t square into xt, this is equal to 0 for t belongs to 0 and 3 pi. Okay, and then the cardinality of the set, this t belongs to 0 3 pi such that xt equal to 0. Okay, we have to find the cardinality of that set, and here 4 options are given. So we just have to calculate how we, this is a question from Strum comparison theorem. Okay, Strum comparison theorem. What is the theorem? The theorem says that let phi x and psi x be non-trivial solution of y double dash plus px into y, this is equal to 0, and y double dash plus qx into y, this is equal to 0, these two equations respectively on any interval I. Okay, where px is greater or equal to qx and px is not equal to qx. Okay, these two conditions, then between any two zeros of psi, then between any two zeros of psi there is at least 1 zero of phi. Okay, this is the Strum comparison theorem. We apply this, just this theorem. Okay, so first it is given that x double dash plus e to the power t square into xt, this is equal to 0. So if we take this x double comparison with this equation, therefore we get here pt, and this is the variable is t. Okay, so pt equal to e to the power t square. Okay, and now if we consider a differential equation with this is the form with the conditions is these two. Okay, so right, if we take a differential equation y double dash plus y Okay, this is equal to 0. That means here qt, value of qt, this is equal to the coefficient of this, that means 1. Okay, and in the interval for all t belongs to 0, 3 pi, pt is not equal to qt and pt is greater or equal to qt, satisfied. Okay, this is satisfied. That means we can take this equation as for qt. Okay, so now the solution of this equation is what is the solution? Now phi x and psi x be the solution of these two equations. Now we just write, so clearly this equation we get the solution is equal to a cos t plus b sin t. Okay, so sin t and cos t are two solutions. If we take psi t equal to sin t, okay, therefore the theorem says that between any two zeros of psi there is at least one zero of phi. Okay, now in between 0 to 3 pi sin t has 4 zeros. Okay, 4 zeros means the zeros are t equal to 0, pi, 2 pi and 3 pi. Okay, so between any two zeros there is at least one zero. That means we get a0 is here, a0 is here, a0 is here. Okay, that means at least what zeros? At least one zero means, and there are three at least, that means total at least 3 zeros. Okay, at least 3 zeros. That means the option, just a minute, here the option number of zeros greater than or equal to 3, at least 3 zeros, that means greater or equal to 3 zeros. So this is correct option, and this means greater or equal to 2 zeros, this is also satisfied. Okay, so these two are satisfied. That means option B and D are correct options in this question. Okay, this is very important question, and this is a new concept or for differential equation, that is Strum comparison theorem. Okay, now go to the next question. The next question is from Picard's theorem. Okay, consider the initial value problem y dash t, this is equal to f of yt. Okay, consider the initial value problem where y0 this is equal to a belongs to r, f from r to r given, and the four options are says that there exist a continuous functions f and a belongs to r such that the above problem does not have a solution for any neighborhood of 0. Option 2 says that the problem has unique solutions for every a belongs to r when f satisfies the Lipschitz continuous. As two options are given in the problem. Okay, now this problem is based on clearly Picard's theorem. Okay, so first we write the statement of Picard's theorem. So Picard's theorem, first part is existence and second part is uniqueness. So if we write the existence part first, then this is says that if fxy is continuous on mod of x minus x0 less equal to a and mod of y minus y0 less equal to b, then the IVP, that is initial value problem, y dash is equal to and fxy, y dash equal to fxy, y at x0 this is equal to y0 has at least one solution. Okay, on the interval mod of x minus x0 is equal to h, where h equal to, we all know that minimum of a comma b by m, where m is equal to maximum of fxy. Okay, for on the interval ab. Okay, so this is the theorem of existence, Picard's theorem, and uniqueness part is if fxy is Lipschitz continuous, if fxy is Lipschitz continuous, on the interval mod of x minus x0 less equal to h, where h equal to this is I not repeat here, and then the IVP has unique solution. Okay, then the IVP has this is the IVP has unique solution. Okay, these two are the theorems of P-codes. Okay, now option here option 1 says that there exists a continuous function of f from R to R such that the above does not have any solution in the neighborhood of 0. Okay, so this is the clear false option. Okay, using the what existence part. Okay, there exists a solution in the neighborhood of 0. That means A is corrected wrong option. The option B says that the problem has unique solution for every A belongs to R when f is ellipsis. This is clearly the uniqueness part. That is, if f is ellipsis continuous, then it has unique solution. Therefore, option B is correct option. Now go to the next one. Next option is when f is twice continuously differentiable, then the maximal interval, that is the m, is a maximal interval existence for the above initial value problem is R. Okay, so this is not necessary that all the time the maximal interval will be R. For example, if we take y dash equal to y square plus 1, then this gives tan x is a solution. From this we can also easily find that dy by y square plus 1, this is equal to suppose dt. If we integrate that, we get y equal to tan x is a solution. Okay, and we know that the maximum interval for tan x is minus pi by 2 to pi by 2, which is not R. Okay, this is not equal to R. That means option C is not correct here. Okay, that means option C is not correct. And option D says that the maximal interval of the existence of the above problem is R when f is bounded and continuously differentiable. Okay, so continuously differentiable and maximal interval existence when f is bounded. And we also here one more concept is that it is ellipsis whenever del f del y is bounded. Okay, so if del f del y is bounded, then it is also satisfies the ellipsis condition. Therefore, that means if this is bounded, if is del f del y is bounded, then the above problem maximal interval is R. There is no problem. That is option D is also correct here. Okay, so this is the questions, and the next question is, just a minute. The next question is let xt yt satisfy for t greater than 0, dx dt this is equal to minus x plus y, and dy dt this is equal to minus y, x0 equal to 0 equal to, and x0 equal to y0 this is equal to 1. Okay, then xt is equal to, what is the value of xt? Okay, so first here y is included, therefore we first solve these equations for y. Okay, so this gives dy by y this is equal to minus of dt. This implies log of y this is equal to minus of t plus c, and if we apply y0 equal to 1, then this gives log 1 equal to 0 equal to minus t plus 0 minus c 0 plus c, just a minute, 0 plus c. Okay, so this implies c equal to 0, that is log of y this is equal to minus of t, that means y equal to exponential minus t. Okay, now we put the value of y is here. Okay, so this implies dx dt plus x this is equal to e to the power minus t. This is clearly of the form dx dt plus px is equal to q form. That means integrating factor this is equal to e to the power integration dt, that means e to the power t. Therefore integration d of x e to the power t this is equal to integration e to the power t into e to the power minus t dt. Okay, this implies x e to the power t this is equal to simple t plus c2 suppose. Okay, now apply the conditions, x0 equal to 1 we get 1 into e to the power 0 means 1. This is equal to t means 0 plus c2. So this gives c2 equal to 1. Therefore the solution is for x, this is x e to the power t, this is equal to t plus 1. This implies x equal to t e to the power minus t plus e to the power minus t, which is equal to e to the power minus t into 1 plus t. So which options are correct here? Option 1 e to the power t plus yt, e to the power t into 1 plus t, e to the power minus t into 1 plus t. Okay, so this is the correct options. And since e to the power minus t equal to 1, this is equal to, we can write y into 1 plus t. Okay, therefore option here, option A and C, option A correct and C correct, that is first and third option is correct here. Okay, so this is the last question for this video. Okay, if you like the content, then please give a like to this video, share with your friends and subscribe the channel. Okay, so thank you friends. And one more thing, today is 15th August, so happy Independence Day to you all. Okay, again. Okay, and so Jai Hind. Okay, thank you.